we have four basic kinds of these proteins. We can have electroneutral pumps, or we can have electrogenic pumps. Electrogenic pumps occur when you are transferring ions and creating an electric, changing the electric gradient across the cell membrane. So let's say you're just pumping protons, and you're not bringing in any protons on the other side, or you're not also taking out an anion. Then you will see a change in the charge from the inside to the outside of the cell. That is electrogenic. If you say have a protein that you're pumping out of the cell, but you couple that to pumping potassium into the cell, then that would be electroneutral, because you have one positive species going out while you have another positive species coming in. Or you can have another form of electroneutral is when you have a positive ion going into the cell being coupled to a negative ion also going into the cell. So you don't change the net charge across that cell membrane. So I have also mentioned that you can have symport and antiport now. Symport means that both when you have these coupled transports, you have both of your ions going in the same direction. Versus antiport, where you have one ion coming into the cell and the other ion going out of the cell. So altogether, that gives you four different combinations for how these thingos work. And so, for example, that is going to be too hard for you to see. But basically, an example of an electrogenic symport is coupling to the import of a proton, the import of sucrose. So this would be done, for example, in a guard cell that needs to build up turgor. It'll pump in sucrose. This is electrogenic because you have a positive species coming into the cell without anything countering it, because sucrose has no charge. It's symport because they're both going in the same direction. All right, xylem loading. Still in transmembrane transport. So we know that xylem cells are dead, which means they don't have a cell membrane, which means they don't really have a way to pump solutes, ABA, whatever, into the xylem, into the transpiration stream. So just inside the Casparian strip, we have a series of xylem parenchyma cells. These xylem parenchyma cells do all of the job of transporting ions and other ions, ABA, hormones, whatever, into the xylem stream. And they do this because they have an enormous number of these transporter proteins, which I was just showing you in the previous slide. Requires quite a bit, and as well as proton pumping ATPases. Proton pumping ATPases are really incredibly useful for plant physiology. And also I forgot to point out on the last one that drought and ABA reduce the activity of these efflux channels.